Next up in our unit on trigonometry is Learning Target 3, Law of Sines. We're going to use this to find missing measures of non-right triangles, because up until now we've used trigonometry only on right triangles, using sine, cosine, and tangent to find angles and missing side measurements. But what if you have a problem like the one below? The one below has a obtuse angle instead of a right angle at 100 degrees, which means that sine and cosine and tangent aren't going to work out correctly, because if you don't know where the 90 is, how do you know where the opposite and the adjacent is for the 20? We really don't know. And since we don't know, we can't use sine, cosine, and tangent in the way we did in Learning Target 3. In order to do these problems, we need a new law. This law is called the Law of Sines. It works for any triangle as long as you can identify which angles and sides are A, B, and C. We always use little letters for our sides, and for our angles we use the big letters. Also notice that the way we're going to find each of those on a non-right triangle is we're going to find them by going exactly opposite. So if I want to find B, I need to go to the opposite side and I find the B side. For A is opposite of the A angle, and C is opposite of the C angle. This is the best way to match it up so that you put together the formula correctly. So law of sines goes like this. A side divided by the sine of A angle is equal to the B side divided by the B angle, which is still equal to the C side divided by the C angle. Since there's three pieces here, you're only ever going to choose to pick 2 out of the 3. So you only plug in 2 out of the 3 ratios. So let's do this and see an example so you can see what I mean by this. So here's our scenario. We have a triangle with a 100-degree angle, a 20-degree angle, and we're trying to find the missing side A, but we're given the side 5. So I'm going to label everything. I have A. A angle is 20. I'm going to find A. B angle is 100. That means across from it is 5, which is B side. C angle I don't have. Across from that would be the C side. The first thing I can do that isn't even taking any trigonometry is find the last angle. The last angle is found by doing 180 degrees minus 100 minus 20. This is going to give me angle C. So the measurement of angle C is equal to 60 degrees. So I'm going to add that onto my picture. 60 degrees is angle C. Now it's time to use law of sines to figure out side A. So since we want to find side A, I'm going to start with that part of the formula. Side A over the sine of angle A. Angle A is given to us. It's 20 degrees. So this is the sine of 20. This is going to be equal to, I'm going to have to use a full set of numbers for this other ratio, which means I need to use a side and an angle that I both know for the same letter. I know that for B. B side is 5 and B angle is 100. So I'm going to put 5 over the sine of 100. See how I have numbers for both the side B and the angle B? If you don't have one of these in your setup, you're not going to be able to solve it. So in order to do this problem, to get the A by itself, this problem says divide by sine 20. The opposite of that is timesing by sine 20. Do it to both sides. So this will remove the sine from underneath the A, leaving us with just A. On the other side, we're going to need to make sure we multiply this correctly. Remember, whenever you're multiplying by a number such as sine 20, it's really technically over 1. So what you're really doing is 5 times sine 20, then divided by sine 100. I'm going to write that out. 5 times sine 20, then divided by the sine of 100. You're going to have to use your calculator to evaluate this. I end up with an A length of approximately 1.74. Make sure you're always rounding to the hundredths place. That'd be the second decimal spot. So that gives me our missing A side. We didn't have to set up 3 of those ratios, 3 of those fractions from the formula, only 2. You're going to see this terminology often as we do this learning target. The term is solve a triangle. When you're asked to solve a triangle, this means to find all the missing sides and angles. So sometimes you might be asked to find one very specific angle or side. But if the directions say solve the triangle, then you need to figure out all the missing sides and all the missing angles in whatever way you can. This is our last example, an example that works a little bit differently. In the example that we first did, we were given 2 angles in the triangle. This time we're only given 1 angle. So let's go through and label the pieces that we know based upon the letters of the angles. I have an A angle here. Across from that would be the A side. B angle is across from the B side, so 21 is the B side. C angle is across from the C side, so C is equal to 34. I'm not going to be able to figure out angle A or B right now, subtracting it from 180 because I only have 1 angle. So let's set up law of sines for what we do have. We can try to figure out maybe angle A or maybe angle B. If I want to figure out angle A or side A, I'm going to have one of those 2 pieces. So I can't start this problem by figuring out A because both those pieces are missing. I do have a side B but no angle B. So I think that's what I'm going to work on first, side B. So we know side B is 21, and its angle is what we're going to solve for. So the sine of B. And this will be equal to the pair of angle and sides that we do know for certain. And that would be the side of 34 across from the angle of 84, our C's. So 34 divided by the sine of 84. So just like in the last problem, we're going to multiply by what's being divided right here. And that is the sine of angle B. So this removes it from the bottom, and now it's over here on the top. Let's rewrite our problem. 21 is now equal to 34 times the sine of angle B over the sine of angle 84. I don't want the sine of 84 here, so I'm going to multiply by the sine of 84. I don't want the times 34, so I'm going to divide by 34. This allows me to get rid of both of these simultaneously. Don't forget to do this on the other side. Sine of 84 divided by 34. So what I need to do is I need to calculate the sine of 84 times 21 divided by 34. And this will give me the sine of angle B. What I end up with is approximately 0.61. It continues on for much longer, so I'm going to also include a 4. We're going to need to inverse sine what the calculator gave us, and that's what will give us B. So B will be equal to the inverse sine of what the calculator gave us. I come out with 37.9 degrees. So that's angle B. Now that I know angle B, I can definitely use it and angle C to find angle A. So 180 degrees minus 84 minus 37.9 will give me angle A. So angle A is equal to 58.1 degrees. So have I found everything? Well, I'm going to write down what I have found. I found a 58.1. I found a 37.9. I have side C and side B. I don't have side A. So I still need to do that. So to find side A, I put side A over the sine of angle A, which I do know. That was 58.1. I'm going to use the same pair of angle and sides I used to begin with, which was the C's. 34 over sine of 84. I'm going to multiply by the sine of 58.1 because that is what is being divided by, and I also do it to the other side. 34 times the sine of 58.1 divided by the sine of 84. Comes out to 29.02. Now I have actually found all the missing pieces of this triangle. You're not going to see much other variety besides these two examples. You do need to run through a few examples in order to get used to the pattern of the formula, setting it up, and solving it correctly. If you have questions, go ahead and send them out to me, write them down in your notebook, or you can always use the text messaging service to get in touch with me. Don't forget to go through, answer the questions, and hit the submit button, and I'll see you guys back in class.